For this lesson, we are going to talk about one extraordinary man and some of the works he did to the concept of motion. And by now, I'm sure you should know what I'm talking about. He's not a person but Sir Isaac Newton. He did awesome work on the concept of motion, so much so that it is seemingly difficult to talk about motion without making reference to him. It is, in fact, it is not even possible. Okay, now let us discuss some of the ideas he brought to the table, and this will lead us to the three basic concepts we discussed under our study of kinematics, which are speed or velocity, distance or displacement, and acceleration. All these are going to be discussed under the topic linear motion. And linear motion is basically the motion of an object or objects on a straight line, from the word linear. Okay, it is the combination of two root words, linear and motion. Linear from the word straight line, it's moving on a straight line or on a straight path, while motion, which talks about the movement of an object or a particle from one point to another. All right, so we are going to discuss these three concepts, okay, if time permits us. All right, let us start with the first one, which is speed. What is speed? The term speed is always used when we are considering the motion of an object as it changes position. Take note, the motion of an object as it changes position or direction. I think direction is the best word to use. Okay, when it changes direction, then we talk about speed. Now, in most cases, the time speed of an object is computed as an average. Why? Because we are putting into consideration of the changes in direction from point A to point B. And of course, there are some things we need to consider before an object gets to point A, gets to point B from point A. All right? So when we do that, we are talking about the average speed. Okay, so let's say an object moved from point A to point B, and then from point B to point C, which is its final destination. Right? So at this point, we can consider the average speed covered by the body from getting to point C. So the average speed it took the object to get to point C can be computed or calculated. So mathematically, average speed is called or is calculated as the total distance all over the total time taken. So for instance, let us take from point, a car moved from point A to point B and from point B to point C. Okay, the distance from point A to point B, it covers the distance of 2 kilometers. And from point B to point C, it covers a distance of, let's say, 3 kilometers. The total distance from point A to point C is going to be 2 kilometers plus 3 kilometers. Am I correct? Yes, of course I am. And let us say it took the object to move from point A to point B under, all right, let's say 3 seconds. And from point B to point C under 5 seconds. Okay, let's use seconds. Okay, of course you know that the standard for time is seconds, while the standards for length is in meters. All right, so let us change these to meters. So we'll just have a uniform standard. So we have 2 meters and 3 meters. Okay. Now we are asked to find the average speed, and we said the average speed is equal to the total distance all over the total time taken, and the total distance here is 5 meters all over 8 seconds. Okay, so this is 5 over 8 meters per second as the average speed covered by this body. This is just a normal illustration, okay, of the concept of average speed. Like you saw here that the SI unit is meters per second. Okay, so therefore we have speed in terms of other quantities. You know, we can have speed in terms of other quantities. So if we have that, our first aim is to convert them to convert the quantities to the generally acceptable standard, which is the SI unit. Okay, once you do that, you can now solve arithmetically. Okay, so that is that about the concept of speed. And let us discuss velocity. But before we talk about velocity, because we cannot talk about velocity without understanding the concept of displacement. So what then is displacement? Displacement is seen basically as the change in the position of a particle in a defined or specified direction. Take note of the two keywords here: change in position of a particle. That's the first thing you have to take note. And the second thing is in a specified direction. Okay, so these two things are very, very important in understanding the concept of displacement. So if an object is at, let's say, point A, let's say an object is at point A1 at a particular time T1, okay, and later on we saw this same object at point A2, okay, at a time T2, we can calculate the change in the position of this body. All right, the change in the position of the body is going to be seen as change in A, okay, which is equal to A2 minus A1. Okay, now if we have this, the change in the position, like we saw in the definition of displacement, which is seen as the change in the position of a body in a specified direction. So the change in this position of a body we are talking about here is A2 minus A1. Okay, and since it takes into account of the direction of the object or the body, then we can call it a vector quantity. So we say that displacement is a vector quantity because of the fact that the word direction is put into consideration. All right. Now, on the contrary, speed, like we saw here, is a scalar quantity, because all through our discussion about speed, we never put into consideration the direction. Okay, and remember, vector quantities have magnitude and direction, while scalar quantities do not or does not have direction. We only talk about magnitude. All right, so we say that speed or distance is a vector quantity, a scalar quantity rather, while displacement is seen as a vector quantity. So what then is velocity? Remember, I said we cannot talk about velocity without making recourse to the concept of displacement. So since we have discussed what displacement is, then let us talk about velocity. Velocity is simply defined as the rate of change of displacement, rate of change of displacement, or sometimes some texts will call it time rate of change of displacement. We are talking about the same thing. Okay, now just like we discussed in speed, we talked about the average speed, because most times a body can cover more than one distance at the same time. So in that case, we are going to talk about, or we are going to consider the average velocity or average speed between or along the time of the journey. All right, so average speed of a body in motion is seen as the ratio of the displacement, all right, displacement, the change in the body, or change in the position rather, and the time interval. Okay, so average velocity, let's use the word V average. V average is seen as the change in the displacement. We use X to represent displacement all over the change in time. Okay, and we said changes, it gives account of one position with respect to the other position. Okay, so let us say we are considering point A and point B. So the change in the position of that particular object is seen as XB minus XA over. So since we're talking about the points B and point A, the time A and time B will also be put into consideration. So we have TB minus TA. So where X is the position and T is the time. Okay, so this is the formula or the ways you can explain or identify the average velocity. Now with this, we have come to the end of this class. In our next class, we'll further our discussion on the linear motion, where we will talk extensively on the concept of acceleration. So see you in our next class.